Suppose we're asked to find the order 2 Maclaurin polynomial for the solution to this initial value problem. Well, what is the Maclaurin polynomial of order 2? Well, let's think about this. We have, it is going to be our f of, or in this case y, but it's going to be f of 0 plus f prime of 0 over 1 factorial x plus f double prime of 0 all over 2 factorial x squared. And you could continue on, but this is of order 2. So we have what we need there. So we have these f's, which are just in fact y's in this case. Let's see what we have. Well, we have y of 0, so we have a 1 here, plus, well, 1 x over y prime of 0 plus y double prime evaluated at 0 over 2 x squared. So we have two values that we're missing. So y prime of 0. Well, we know that y prime of 0 plus 2y of 0 will just equal 2 times 0. Well, what is y of 0? We have, that's going to be equal to 1. So y prime of 0 equals negative 2. Because we get the 0, we get the 1, we just solve it. So we already have made our next step right here. We have 1 plus 2x plus y double prime of 0 over 2 x squared. So we just have this last part to solve. Now, we know this is our differential equation, so let's take one more derivative. If we take the derivative with respect to x, what do we get with implicit differentiation? We get a y double prime here plus a 2y prime is equal to 2. So therefore, we know y double prime of 0 plus 2y prime of 0 is going to be equal to 2. Now, we know y prime at 0 is just negative 2. So we get a negative 4 equals 2 y double prime of 0. Then we solve and we say y double prime of 0 is equal to 6. So our degree 2 Taylor polynomial should just be 1 plus 2x plus 3x squared. And that's our final answer for what the order 2 Maclaurin polynomial will be, given this initial value problem. One small error that you may have seen here is that when I plugged in y prime of 0, it's negative 2, I only put a 2 here. Really, it should be negative 2. So our conclusion is that we have our order 2 Maclaurin polynomial of 1 plus negative 2x plus 3x squared.